Hello, welcome back to tomorrow's teaching and your Python course. Today we are talking about variables. You see, I'm here in Google Colab like before, and very quickly to remember what we said last time, we have the print statement, it's the first line here in my notebook, and I have an arithmetic expression 2 plus 3, and the first time I put it in quotes means it's not going to be evaluated by Python. It's going to just be printed out as it is. After the comma, I have the same expression without the quotes. So now this is going to be evaluated, and then I have the separator, which will separate the output. And I set this to nothing, which means that the two outputs, the quoted and the not quoted one, are not going to be separated by anything. They are just going to stick together. If you want to know more about this, go to the previous session where we discussed the print statement. So now I'm going to execute this with Control and Enter, and we will see it will take a moment to connect to the Google servers, and then it will take a moment for the Google servers to start an instance of our Python, and now I get my result. So let's continue. Today we want to talk about variables. Variables are the very essence of computer programming, because without them we cannot remember anything in our program, right? Our program can only work with the values that I have entered at the beginning into the code of the program. But whenever something changes, the program is unable to adapt or to do anything new. The program needs to remember stuff, and this happens with variables. A variable is a name that represents a value, and this value is stored in the computer memory for the duration of the runtime of the program, right? So it's not storing in the way like you would store something on a hard disk where it stays, but it is storing only while your program is running. When the program terminates, all the variables are forgotten. So it's a temporary storage of values under a name. It's a little bit like in mathematics, where you have x and y and z, and these have the values, to them. But unlike in mathematics, where the value is usually a number, a variable in programming can hold many types of data, numbers also, but also text, strings. So for example, hello world can be the value of a variable, whole files or complex data records, a database, entry can be in a variable. So a variable is a very variable thing, right? So it can hold multiple things. But every variable has a type, so it can hold only one kind of thing, right? You cannot, in the same variable, you cannot put multiple things. One variable is one thing in memory, one value. The easiest kind of variable use is just to assign it a numerical value. So here I take a simple variable called a. Variables can have any name you want that begins with a letter, and then it can also contain digits that should begin with a letter. So here I take a very simple one, just a, and then I use the single assignment operator. This is called an assignment operator. It's not really an equal sign like in mathematics, because an equal sign would say they are equal. The assignment operator does something, right? It moves the 23 into the A. The A you have to think of as a memory location, and now the number 23 goes into this location A. So I assign the value, this is why it's called an assignment operator, I assign the value 23 to A. And after that you see a comment which begins with this hash sign, the hash mark. This says whatever comes after that until the end of the line is a comment. So Python, please ignore that. It's just for the reader of the program. This is very useful because we can document our programs in this way inside the program too. We can say what a line is doing, or if we have a particular clever calculation, we can tell the next programmer who will deal with this program what this is doing. That's very important to document your programs, because often you're not the only user. You work in teams, you work in groups, perhaps you program something and later somebody else has to maintain it. So it's very important to leave sufficient comments so that people know what your program is doing. We will talk more about this later. So in this case, let's just run this to see what will happen. And when I execute it, it finished, right? This was it. It was executed. You see on the left side, you have this little, here you have this little tick, 0 seconds. This tells you the program was executed, took 0 seconds because it was so fast, took less than 1 second. And you don't see anything. Why don't you see anything? Well, because you didn't tell it to print anything, right? You just said A should be 23, and now the number 23 has been moved into this variable A, and that's it, right? There is nothing more to do there, right? The program is finished. Now you have a variable A that has a value 23, but you don't know about it. So if you want to see whether this worked, you have to do something with this variable. For example, you have to print it. And here we go. Show that Python knows about our variable, and then we say print A. So let me print A, press Control Enter, and then you see now I get 23. And now, for example, if I had said something different here, like print B, you would see that this will not work. I execute this, and now I will get an error message. Name error, and it tells you where it is, and at the last line, name error, name B is not defined, right? So it does not know what B is, but it knows what A is because in the previous cell we defined that A, so I can press again and then you see it works. By the way, if you want to remove all these outputs, you can click here on the left side of this output area, and then you will get a menu which allows you to say clear selected output, so then you're back if you want to do it again without having the previous output. You also do learn something else from this example. You see that the cells are connected within a notebook. So what happens in one cell influences the next cell, right? And it is with the order you execute them. Obviously, they're going to this environment. So you have to execute the first cell, which assigns the number 23 to the A, and then you can execute the second cell, which prints it. And they will communicate because they both have the same Python environment behind them. It's the same machine on which this is running. So after you assign something, it stays there, but only for as long as your Python instance is running. Because we have this free environment, after a while, Google will switch it off. It will just kill our environment if we don't do anything, or if we do too much and we exceed our free credits that we have, then Google will kill your Python, and then all the variable values will disappear. This is no problem normally because you can just restart it. You can go through your program and execute everything again. And there's a handy button for this here also on the top. If you look, you see run all cells in a notebook. So this makes sure that you don't have to click everyone separately. They are all executed in sequence as they are in the notebook. But you have to remember this. So you cannot just go away now, come back tomorrow and expect your variable to be still here, right? It will not be, except if you have a paid Google Colab membership, right? You can. Now let's look at the next one. Here we have another one where I have a more complex operation, just to show you it does not matter how much you calculate. You can have many operations within the same thing, and we get 15.5 here, not a problem. And I can also have a variable using the values of other variables in its assignment. So here I assign B a value that is 2 times A. And so in this way you can construct very complex operations where one variable is dependent on the value of other variables and builds upon them, and then you can make in multiple steps, very complex things happen. You should name your variables consistently, use lowercase letters if no other rules are given, make the names descriptive, don't only call them A and B. We do this here because it's easy and for the beginner it's less confusing, but when you really write a program and it asks for a name, for example, then call the variable name. If it asks for an age, then call the variable age. Use the fact that you can have multiple letters, you can have whole words, whole sentences as variable names, because later, if your program is only A, B, C, D, E, you will have great difficulty remembering what these variables are doing, and nobody wants to maintain such a program. If you work for a company as a programmer, you will be given probably some company guidelines on how to name your variables. But generally, be consistent, start with a letter, and use descriptive names is always a good idea. Now you see what happens in our next example. I have here something called Peter3. This also works, right? I can execute it, it will print 42. The Peter is written with a big P. This is no problem when I'm working alone. Again, I can do whatever I want, but you should avoid this normally because there are often conventions. If you work in a group or if you work for a project, they will have naming conventions, and often the big letters have a particular meaning. For example, often, they signify constant values instead of variables. So be careful to name your variables as your environment, your social environment, or your employer wants you to. And now I want to print it here, the Peter 3, in small letters, and then you will see, you can already see it, right? Name Peter 3 is not defined. So this tells you that Python is sensitive to case, right? The Peter 3 with a big P is different from the Peter 3 with a small p. So be careful again, be consistent in the way you name your variables. There is one more thing. Colab offers you auto-completion of things while you are programming. So now I'm here, I print, and then I open the bracket, and then it will offer me what I can print at this moment. Print, and then it tells me what I can put into there. Or if I'm just typing, it will also suggest what I can print. So I want to type Peter 3, but then I start typing P, then I start typing an E. And so you see that Python tries to guess down there what I might want to print. And you see that, among other things, it offers me Peter 3, the correct Peter 3 with a capital P, right? So I can just choose this with a mouse or with cursor arrows up and down, and then press enter to select it. And then this will be entered there. This is not useful with the programs we are writing now because the names we are using are very short, but this can be useful when you have very long variable names and you don't want to type them. And this big box with suggestions that you see floating here now, if I want to get rid of it, I just press escape on my keyboard and this will disappear. So variables can also have string values. The variable greeting can have the value hello world. And again, like I did with the print statement, you need to quote the string so that Python knows not to evaluate it, not to try to understand hello world, but just to print it. So let's go in here and try this out. I press Control Enter, and you can see that this works. Out comes hello world. I need to quote the string, right? I just said it, but let's see what happens if I don't. So I just go there, and now without quoting the string, I press Control Enter. I try to execute this without quoting the string. And you will see that I get an error message again, invalid syntax because I have not quoted it. So the program doesn't know hello, it doesn't know world. On the other hand, of course, you never want to quote a variable name that you want to use as a variable, because then it will take the name as a name and not as a variable. So if I say greeting is hello world and then print greeting in quotes, now try to guess what will happen if I execute that. I will get greeting and not the value of greeting, which would be hello world. So try to really, in your mind, sort out what these quotes are doing. They just tell Python, ignore this, don't evaluate it. So if I put it around a variable, I don't get the variable evaluated, it gets ignored, right? It gets just printed as it is. Okay, one last chapter we need to talk about, f-string. So far we know how to print simple text and we know how to print the contents of a variable, but there is also an easier way to combine text with variables. So if you look at this example here, we can print a literal string, a quote by Shakespeare. We can store the string in a variable and we can print the variable, right? So these are multiple things we can do here. But sometimes we want to combine a text and the value of a variable in a single output. For example, we might want to say something like the author is and then Jane Austen. And how do I do that if the Jane Austen is not a string literal, but if it's something that comes out of a variable? And there are multiple ways of doing it. Let's see. One would be what we already talked about. I say print the author is, comma, Jane Austen, right? This is one possibility. But then I get the separator. I have to change the separator value if I want to format it more interestingly, is not the most easy or more convenient way. Another way to do it is to add two strings together with a plus sign. When you add two strings, what happens is not an arithmetic addition, obviously, which is impossible, but it just sticks them together. This is called string concatenation. And you see this here in action. Author is Jane Austen, print the author is, and then plus author, right? Let me execute this for you and see how it works. The author is Jane Austen. And what happens here now is different from what happens if you put a comma, right? It's perhaps interesting to see why. We don't get a space between the text and the variable. And why does Python here not add a space? Because who adds the space? Print adds the space if it has multiple parameters. But here it does not have them. Here it has only one, because the string concatenation happens before this value is given to print. So I have print, and now print sees only one value. It sees one string because the string concatenation has happened before. So first, Python evaluates everything inside the brackets, and then it gives whatever has been evaluated to the print statement. Now the problem is this: string concatenation is nice, but it works only with strings. If I try to use a number, I get an error. So look at this here, for example, the year is 1813, and then I say Pride and Prejudice was published in plus year. And this is not going to work. Why is it not going to work? Because year is not a string, so they cannot be concatenated. Year is a number, and the addition of a string and a number doesn't make sense to Python, right? It can understand adding two numbers, which is an arithmetic operation. It can understand adding two strings, which is a concatenation. But what happens if I add a string and a number? It's undefined, right? And so it says you can only concatenate string, not int to string. So this doesn't work. There are ways around it, but there's also a more elegant solution, which we will look at now. And these are called formatted strings or F strings. And in these F strings, you just put the letter F right before the opening quotation mark, and inside the string, you place any variable names inside curly braces. And these curly braces then get replaced with their variable name, get replaced by the value of this variable. So the F tells Python this is not a normal string, scan it for curly braces and replace the values. And so you see how it works. Author is Jane Austen, year is 1813, print F, and now you have the small f. The F means now this is a formatted string. And then comes the string, the author, and in curly braces, author published a novel in curly braces year. And what is going to happen now is Python is going to replace author and year with the values of these variables and then print the whole thing, print the result. Let's see it in action. Here we go. The author Jane Austen published her novel in 1813. This is much easier to write, and especially if you have lots of variables and a complex formatting, and so it's used very much. Okay, thank you, and see you next time. Bye-bye.